Good morning, everyone. My name is Mya Sharpe. I'm a graduating senior at Oregon State University, and I'm a NOAA EPP Scholar Class of 2020. And my project is on the analysis of clusters and wild Atlantic salmon smolt scales in the East Machias River over a 7-year time series, working with Ruth Castro and Brandon Ellingson under NOAA's Northeast Fisheries Science Center. Yeah. All right, so East Atlantic salmon were listed as endangered in 2000 after a decade of population decline. And some of these threatened drivers for decline are because of anthropogenic drivers. For example, restricted ecosystem connectivity like dams and diverted waterways, habitat degradation, commercial and sport fishing, and climate change. So we know that the conservation of Atlantic salmon is important for the restoration of the species, but it's also important for the ripple effect that it can have on our ecosystem and our local communities socially and economically. And this illustration is showing some of those social and economic advantages. The average female Atlantic salmon will deposit about 7,000 eggs. And from eggs to sac fry to par to smolt to post-smolt, smolt to salmon at sea, where they grow to much faster in saltwater than freshwater. And fun fact, if you didn't know, salmon at sea that's been about 2 years there can go to be about 28 to 30 inches. So my study is focusing on this life stage of the smolt, that migration from the freshwater to the marine environment. So migration occurs between late April and early June. So we'll be focusing on that transitional growth between the freshwater from the river to the sea. All right, so on the left, we have an image of an adult scale. And the margin right there that is highlighted, shown on the right, is freshwater growth. So what we call plus growth in the freshwater growth is what we characterize as runoff circuli in the adult scale. So the larger significance of the project that my mentor is working on is to be able to look at an adult scale, be able to characterize the runoff growth, and also be able to back calculate some things at the size the adult was at the smolt. So what is back calculation? It's a technique that uses a set of measurements made on a fish at one time to infer the length at an earlier time or earlier times. So there are numerous formulas with correction factors. Most are based on the concept that the growth increment on the calcified structure, in this case of our study is scale, is a constant average proportion to the growth increment of the fish itself. The purpose of my research is to characterize plus growth in smolt scales to improve recognition in adult scales and accuracy of back calculated lengths. Also to improve our understanding overall of plus growth and how it relates to smolt migration in the East Machias River, and to explore some relationships of plus growth with possible environmental drivers of this transitional growth. So this is a map of the East Machias River watershed, and this little red dot right here is the general location of where the Golden Beach school traps shown on the right are located. They're located on the river right before the smolts leave the river to enter the sea. And in these Golden Beach school traps, the smolts are caught. They're put to sleep to reduce stress for sampling. So tissue samples are taken as well as scale samples, but we're focusing on the scale samples. So from these scales, they are then cleaned and mounted between slides for imaging. And from these images, you can determine age, life history, and rearing origin. So if you never analyzed a scale before, this may just look like a fingerprint to you. I mean, it did to me when I first started, until I began to see what it actually allows us to find out. So when I would receive these images, I would begin in the focus. And from the focus to the next point, the first annulus. An annulus is just a complete year of growth. And the rings between that are called circuli. So you see that the circuli are tightly spaced. That's just showing slow winter growth. Summer growth is experienced in the first year. It's just not shown on the scale because the salmon was just so small at that point. So from the first annulus to the second annulus, you see the circuli get a bit more wider, and that's showing rapid summer growth. And following that, the circuli get a little tighter, which is showing winter growth. So following the formation of the second annulus, the circuli following that is what we characterize as plus growth. For our age 2 smolts, Throughout the time series, the number of fish that we sampled range between 2 to 80. The occurrence of plus growth percentage range between 93% to 100%, and the average number of plus growth circuli seen range between 3.4 to 6.1. For our, wait, go back real quick. I forgot to mention. All right, in 2013, that's the year that we had the most sampling. So we're going to focus on this year and age 2 a bit more closely later on. For our H3 smokes throughout the time series, the number of fish range between 3 to 14. The occurrence of plus growth range between 66.66% to 100%, and the average number of plus growth circuli range between 2.5 to 5.16. Looking at the plus growth circuli for both ages throughout the time series, we see how they differ. The age 2 smokes made about 70% of our data, while age 3 made up about 30%. And this proved to be statistically significant by the p-value that was obtained. Looking at plus growth across the migration week for both ages throughout the time series, just by observing the graph, we see that there's a strong positive linear trend, and it did prove to be statistically significant as well. Now looking at the plus growth across the time series for age 2, but by year this time, we see that there wasn't a trend, and it didn't prove to be significant due to a noticeable factor. Now, looking at the H2 and 2013, like I mentioned, the plus growth seen throughout the migration week did increase and proved to be highly statistically significant as well. Now, for the possible factors that are driving the plus growth, we can begin with looking at precipitation. The trend line does show that it is positive. However, with the R-squared value that was obtained, only 2% of the precipitation data was explained by the migration. So looking at temperature next, since migration occurs in the relatively warm months already, temperature is relatively high. So throughout the course of the run, temperature does increase, and 65% of the total variability is explained by the migration. Now looking at fourth length with the migration week, we can see a strong positive relationship, and 88% of the total variability is explained by the migration week. And this is all collected from 2013 data. So our major findings is that migration week had a larger effect on plus growth circular method than year did. And plus growth was found on majority of the smolt scales and composed a notable portion of the total scale. And this can be a possible source of error of back calculation if it's not considered properly. Circular count, temperature, fourth length, they all differ significantly by migration week and increase throughout the course of the run. However, based on our data, precipitation did not have a strong relationship with the migration week. So not many studies look at plus growth. So I compared my research to a previous intern under the same mentor, Rachel Kim, where she looked at plus growth increment against the standard week in 2019 for H2 in the narrow radius upstream and downstream and the Sheepscot River. And the plus growth increment is the actual measurement of the plus growth on the fish, and that's due to her project being in person. Since mine was virtual, I looked at the plus growth circulite count as a proxy. So in both, in her 2 rivers and my river, we see that there is a positive trend throughout the migration. I also did compare our fourth length data. So for my fourth length data in 2013, you do see an increase throughout the course of the run. However, there was no steady increase in fourth length across her migration for these rivers. But there's something notable that I wanted to point out in her data. You see the second to last one spot in the upstream Narragansett River to the next one. That is a large jump, which means that this site can suggest compensatory growth. Because fish size and marine entry can impact survival because it can impact migratory behavior, thermal tolerance, and also predator-prey dynamics. So therefore, migration can be a possible reflection on the increased growth that is needed to obtain a size that is advantageous for the smolt to survive. So the benefits to NOAA is to learn more about Atlantic salmon freshwater rearing habitats and to improve our understanding of biological systems which operate within the Northeast U.S. rivers. And for future endeavors, we can look at the analysis of plus growth in post smolts and adults to improve back calculation to smolt sizes. Look into smolts from additional rivers in Maine. Research plus growth and hatchery origin scales. Also larger sampling sizes to analyze relation, age, and growth, and explore more relationships with plus growth and other environmental variables.
Okay, so I'm a computer science major, and you analyze all these samples that you collected individually yourself?
Yes.
Okay, so have you ever considered using a program to run it and measure for efficiency, like age groups and growth rates?
That is a good idea. I'm not sure if there is a program for that. I would have liked that over the summer though, because I got hundreds of skills and just counting the circular throughout the entire month and getting hypnotized by the lines.
Actually, I'm interested in pursuing a research project using cohort shells, which have similar scales. They have like similar problems, and I think that'll help you with your future endeavors of further increasing your data size with your sample sets. Also, you can end up making the program to factor in other variables like the temperature control and stuff like that. So yeah, that's a good thing.
Partnership.
Also, I had a question about your data set. I know that you said with the surgery count and everything, the P rate was under 0.05. I was interested in what data did you end up throwing out that was over 0.05. Because once you get to a data collection set, you're supposed to anything less than 0.05 keep in the sense of peak size, but anything over that you throw out. I was interested in what data collection you put out.
I'm interested in data collection. I use everything that was from a viable scale.
Okay.
Yeah. So I had a question about, well, it's kind of a two-part question. I wanted to ask if you went out with your mentor when you were doing the self-collection for the scales. Yeah, I didn't get a chance to. I was only on the end of receiving images, but I would have liked to be there. So I do plan on doing a site visit over the summer, so yeah, hopefully I'll get to see the process. Okay, and then the next part of that question is if you know the answer. Do you know how, like what technique that you use to put the smolts to sleep? I knew I was going to get this question and I do not have the answer. Yeah, I'm not sure whether it's injected or if it's a gas or it's something topical. I'm not too sure, but I can text her and I can get back to you today. Okay, thank you. Thank you.
Yes. So does back calculation take into effect, for example, like if some salmon experience stunted growth in an area, for example, with hypoxia or salinity issues? Does that take into account in that calculation, stunted growth, for example?
I believe you can still use back calculation for that. If it's shown on the scale, if something was conditioned on the scale, you could probably use that back calculation technique.
So you use the distance between each of the rings as part of the calculation?
Yes.
Yeah, I was going to ask about the use of the rotary screw traps. Is there a reason they were used over other conventional driving methods?
I'm not sure. Maybe because, I don't know, if it holds a bigger amount, a larger amount of smolts that are coming in. That's something I can look at. I can ask my mentor about to why they use that method opposed to other methods. It's a good question.
Great presentation, Maya. And I know you looked at precipitation, but did you guys ever think about comparing against like the North Atlantic oscillation, seeing different oscillation periods of temperature growth rates? Like you could compare it like the NAO index and just have like growth rates.
We didn't think to look at that, but that's something we can look at. But other environmental variables that we're thinking about, we're looking at the amount of snowfall that's seen earlier in the year and how it could affect stream levels and river flow, and also the amount of daylight that the smolt can experience. We can add that to the list as well. Thank you.
Yeah. Thanks.
So,
yeah, really great talk. I was wondering,
with your scales, did you consider using other parts like otoliths instead to do the growth? Why did you choose scales?
I didn't choose the scales. It was presented to me in the beginning of our research that you're going to analyze scales in this river, and it was my job to figure out what I wanted to do with the analysis.
Okay, thank you.